Hello dear students, welcome to Physics Focus YouTube channel. In this video, we will be discussing kinematics PYQ from January 2024 attempt. Before this, we have discussed ray optics PYQ. The link for the video you will find in the description. As all of us know, revision plays a very important role in our preparation journey, right? On our channel, you can find revision videos for different chapters. Today we are discussing kinematics PYQ. Before that, you can check out motion in 1D and projectile motion revision videos, the link for which also I am putting in the description. Right, now let us start with this video. Okay, so let us start. The first question that we have, it is from your 27 January shift 1 question. Now before we start, I will urge you people to pause the video, try the question by yourself. After that, you can look at the solution part. Let us see the question. It says a particle initially at rest moving from reference point x equals to 0 along x-axis. So t equals to 0 starts from rest, that means u is 0 and it starts from x equals to 0. This is the initial situation with velocity v that varies as v equals to 4 root x meter. V equals to 4 root x meter. Fine. The acceleration of the particle is dash meter per second square. Now, velocity is given to you as a function of x. Velocity is given to you as a function of x. They are asking us acceleration. We know two relations. What does our theory tells us? Acceleration we know is given as dv by dt. When velocity is given as a function of time, we can see dv by dt. Also, we know acceleration is given as v dv by dx. Now, because velocity is given as a function of x, we will be using this relation. Let us see. So, a is equals to v. V is 4 root x and dv by dx. dv by dx, if we differentiate this, how much we will be getting? This will come out to be 4 into root x differentiation will be 2 root x. How much are we getting? 2 times root x cancels. A is equals to 4 to is 8 meter per second square. So the answer for the first question is 8 meter per second square. Let's look at the next question. Okay, next question. It says a bullet is fired into a fixed target. It loses 1/3 of its velocity after traveling 4 centimeter. Let's see. So let's consider a fixed target. Assume a wooden plank or something, right? A bullet is traveling with a speed of v. After traveling a distance of 4 centimeter, it loses 1/3 of its velocity. If it will lose 1/3 of the velocity, that means v minus 1 by 3 v. 2/3 of the velocity will be left. So at this position, how much is the velocity? 2/3 of the velocity is left. Fine. Next it says, it penetrates further p into 10 power minus 3 meter before coming to rest. Find p. Okay. Let's see. So p into 10 power minus 3 meter. This is what the distance it is traveling before coming to rest. So over here v becomes 0. It's a considering that because it is moving in the same body, obviously the acceleration will be same. That is your retardation because it is stopping. So the retardation will be same in this case. Let us see. First of all, we will apply equation of motion for this part of the journey. Then we will apply equation of motion for second part of the journey. Let's see what we can write down. Third equation of motion. V square is equals to u square plus 2as. V square. Over here velocity becomes your 2 by 3 v square. If we do it, 4 by 9 v square is equals to v square plus 2a into displacement. How much is displacement? 4 centimeter, which I am writing as 4 into 10 power minus 2. Well and good. If we solve it, we will be getting over here minus 5 by 9 v square is equals to 2a into, which I can write as 8a into 10 power minus 2. Okay, equation number 1. Let's look at the second part of the journey. If we look at second part of the journey, again applying third equation of motion, v square equals to u square plus 2as. V, finally speed becomes 0. In this part of the journey, initial speed was 2 by 3. So square of that, it will become 4 by 9 v square plus 2a into s. S is displacement is p into 10 power minus 3. I'll rearrange this. We can write it as 4 by 9 v square is equals to 2ap into 10 power minus 3. Equation number 2. Let us solve 1 and 2. 1 by 2. If we do 1 by 2, what we are getting? Minus 5 by 9 v square minus 4 by 9 v square. If we divide that, it will come out to be basically 5 by 4, right? V square by minus v square by 9 will cancel. So we will get over here 5 by 4 is equals to 8a into 10 power minus 2 divided by 2ap into 10 power minus 3. A cancel, this is 4 times, then we will get over here P is equals to 16 by 5 into, this is your 10, 2 times P is equals to 32. So our answer for this solution comes out, for this question is basically 32. P value is coming out to be 32. Let's move. Yeah. So the third question we have is, it is shift to question. What it says, a body falling under gravity covers 2 point A and B separated by 80 meter in 2 seconds. Motion under gravity question. So the figure, let us draw it. Let's say a particle is dropped from certain height. It point A, point B. 2 points it crosses through, 2 points which are 80 meter apart, and the time taken is 2 seconds. Okay. Next it says the distance of upper point A from the starting point is dash meter. That means this distance they are asking. Let's call this as h, and the time taken is t. Let us assume that the time taken from starting point from the top point to A point is your t, right? Let us see what can we write it over here. Motion under gravity, basically we will be using equation of motion. Second equation of motion, let us apply. S is equals to ut plus half at square. First of all, in the upper part of the journey, that is from top point till A point, what is our displacement? It is your h. Because it is downward displacement, I am using sign convention minus h. U is 0, initial speed is 0, minus half gt square, right? G is downward, therefore minus. What are we getting? H is equals to half gt square. Equation number 1. Then what happens is, from top point till B point, how much is the time taken? Time taken will be t plus 2 seconds. And how much is the displacement? Displacement is h plus at. So I can write it h plus at is equals to minus 1 by 2 g into t plus 2 whole square. I hope this is okay. Let's see over here, this is our equation number 2. Equation 1, equation 2. Let's put this h value over here. What do we get it? 1 by 2 gt square plus at is equals to, this is a plus b whole square. Let's open this bracket. 1 by 2 g t square plus 4 plus 4t. Okay. So half gt square plus at is equals to half gt square plus 2g plus 2gt. I hope this is okay, right? Okay. Half gt square cancels. 80, this is 2g. 2g is basically 20. So 80 minus 20 is equals to 2g, that is 20t. So what do we get it? 60 is equals to 20t. Cancels out. T value comes out to be 3 seconds. T is coming 3 seconds. Let us calculate. T comes out to be 3 seconds. So we have to find out this. We can use this equation. Let's put t equals to 3 seconds. H is equals to 1 by 2 g into t3 3 square, right? 5 9 is 45. So the answer for this one is 45 meter, right? Let's move to the next question. Okay, next, it's 29 January shift 1 question. A body starting from rest with constant acceleration covers displacement s1 in time p minus 1 second in first. So s1 displacement in p minus 1 seconds. Okay. Next, and s2 in first p second. S2 in p seconds. Okay. Next it says the displacement s1 plus s2 will be made in time. Fine. Again, it's a constant acceleration. Again, equation of motion question. They are asking us s1 plus s2 displacement total in how much time it is covering. So how to do it? Equation of motion, we have to use it. First of all, let's apply second equation of motion for this part of the journey. What can I write? S1 is equals to, initially it starts from rest, so u is 0, half a time is p minus 1, p minus 1 whole square, right? We can open the bracket over here. S1 is equals to 1 by 2 a p square plus 1 minus 2p, right? This is our equation number 1 for second part of the journey when it is covering S2 displacement in p seconds. So what can I write it? S2 is equals to 1 by 2 a p square. Fine, equation number 2. Let us add these two equations, S1 plus S2. S1 plus S2, what will be getting? Half AP square, and this one we can write it as 1 by 2 AP square plus a by 2 minus 2 AP by 2, which is AP only. Fine. This is what we have got it. Considering, we have considered that S1 plus S2 is in time t. S1 plus S2 distance or displacement is in time t. So what can we write it? S1 plus S2 is equals to half AT square. Okay, total for now, initially we applied for S1 displacement, for S2 displacement. Now for full journey for S1 plus S2 displacement, let's say that it goes in time t, it takes time t, so half AT square. How much we got S1 plus S2 displacement over here? Let's see, 1 by 2. So I can write over here now this equation and this equation. Let's equate them. 1 by 2 AT square is equals to half AP square. This is half AP square, half AP square. This will become AP square. So I can write it AP square plus AP minus, sorry, this is your A by 2 minus AP. Okay. A cancels out. T square is equals to 2p square plus 1 minus 2p. T value comes out root over 2p square minus 2p plus 1, right? This is our answer. Now please check the option. Which option have they given? This one, 2 root over 2p square minus 2p plus 1, option number 2. Option number 2 is our correct answer. Let's move to the next question. Yeah, so the question we have is, a ball rolls off the top of a stairway with horizontal velocity u. The steps are 0.1 meter high and 0.1 meter wide. Okay, let's draw the situation. Staircases are given to us, right? Okay, this is the situation. Now, it says that the height of this is, all are identical, 0.1 meter, and the width is again 0.1 meter. The minimum velocity u with which the ball just hits the step 5 of the stairway with root x meter per second. Okay, so let's say that from here we give a velocity u. What should be the minimum velocity such that it hits the fifth step? Fifth step means 1, 2, 3, 4, 5. If we want that the ball reaches at the fifth step, that means it should be, the projectile should have this type of trajectory. It should fall like this. How much should be the horizontal distance? The horizontal distance should be equals to the distance, that is the width of the 4 steps. 1, 2, 3, 4. If it covers the horizontal distance equal to 4 steps, automatically it will go on to the fifth one. So this range, what will be the range of this projectile? Range of this projectile, because the ball is having a projectile motion, range will be 0.1 into 4 steps, 0.4 meter. Well and good. How much down it should come? It should come 1, 2, 3, 4, right? If it covers this much vertical distance, automatically it will come on to the fifth one. So R, we have got 0.4. Similarly, height it should come down is again 0.4 meter. It should cross 4, then it will reach on to the fifth one. Now this is range formula. What is our range formula in horizontal projectile? R is equals to u root over 2h by g. Let's substitute the values. R is your 0.4. 0.4 is equals to u root over 2h. H is 0.4 by g, which is again 10. Let's square it. We will get it over here. 16 by 100 is equals to u into, this will be 0.8, 8 by 100. Fine, 8 by 100. How much we get it? U square, 100 cancels out, 2 times U square is equals to 2. So U is equals to root 2 meter per second. Now if we compare with the data which is given to us, so we can write X is equals to 2. So answer for us will be X equals to 2. Let's move to the next question. Yeah. The next question, 29 January, shift 2. A particle is moving in a straight line. The variation of position x as a function of time t is given as x is equals to, so we have x is equals to t cube minus 6t square plus 20t plus 15. This is what the position function as a function of time t. Position varies as a function of time t. Next it says the velocity of the body when its acceleration becomes 0 is. They are asking us velocity when acceleration is 0. Let's see. From this x we can find out velocity as a function of t. What it will be? V is dx by dt. So we'll get over here 3t square minus 12t plus 20. This we have got our velocity function. Let's calculate acceleration. So acceleration is basically dv by dt, right? From this if we differentiate it, 6t minus 12. At what time acceleration will become 0? So acceleration 0, 6t minus 12 is equals to 0. So t value comes out to 12 by 6, which is 2 seconds. So at t equals to 2 seconds, acceleration is 0. Now let's substitute 2 seconds in our velocity function. This v at 2, 3 into 2 square minus 12 into 2 plus 20. What are we getting? 4 3 is 12 minus 24 plus 20. This is your minus 12 plus 20. So v value comes out to be 8 meter per second. Answer for this question will be 8 meter per second. Now check the option. Which option is giving us 1, 2, 2? Second option is giving us 8 meter per second, right? Let's move to the next question. Okay. So the question we have is, a particle of mass m is projected with a velocity u making an angle of 30 degree with the horizontal. Okay. Projectile u making an angle of 30 degree with horizontal. The magnitude of angular momentum of the projectile, about the point of projection where the particle, when the particle is at maximum height h is. Basically we have to find out angular momentum. Like this will be the path of the particle, right? They are asking us angular momentum when particle is at this topmost point. Ideally in our regular lectures we do this question in our rotation chapter when we study angular momentum, but this is a PYQ series, concept of projectile is also there. So let's see the question over here. So at this point, when it is at the topmost point, they are asking us angular momentum L, right? Angular momentum, what is our formula for angular momentum? It can be written as L is equals to R cross P. R cross P, RP sine theta, which I can also write as R perpendicular P. I hope this point is okay. R perpendicular P. Now P is your linear momentum. What is the velocity at the topmost point? We know in case of projectile at the topmost point, velocity is u cos theta, right? Now over here, about the point of projection, we want to find out angular momentum. What we'll do, let us extend the line of this velocity, that means velocity line of motion, and we'll drop a perpendicular from this point, from the point of projection, which gives us this perpendicular is acting as your actually R perpendicular. So this is your R perpendicular. Now if you notice carefully, this R perpendicular is equivalent to what? This is nothing but height, the height of the projectile. Now in this we will substitute it. So magnitude L will be R perpendicular, which is h into momentum, linear momentum will be mass into velocity, which is u cos theta. Fine. How much is the height, maximum height in case of projectile? U square sine square theta by 2g into mu cos theta, right? Theta value is 30 degree. Let's substitute. L is equals to u square sine square theta, that is your 1 by 2 whole square, this which comes out to be 1 by 4 2g into mu cos 30 root 3 by 2. Finally L value will come out to be, when we will simplify it, we will get over here root 3 mu cube by 16g. Please see over here 4 to 8, 8 to 16. So angular momentum magnitude comes out to be root 3 times mu cube by 16g, right? Now in the 4 options that you will check, it will be your option number 4. I hope this is clear, and a good question, decent question. We do it in your coaching. You must have, means this question is a standard question, right? This question is done in lectures also. So let's move ahead. Yeah. So the question we have is, this is 30th January shift 1 question. The displacement and increase in the velocity of a moving particle in the time interval of t to t plus 1 are 125 meter and 50 meter per second respectively. That means in the 1 second interval from t to t plus 1, let us draw the situation. Let's suppose a particle is moving and at a specific time, that is t, to the next second, that is t plus 1 second. In this journey, it covers a distance of 125 meter and the speed increases by 50 meter per second. Okay. So if let's suppose over here I assume the speed to be u, that means at tth second if I assume that the speed is u, over here the speed will be how much? U plus 50, right? It says the distance traveled by the particle in t plus 2th second. That means this is t plus 1 second, t plus 2th second. This is what, in this interval they are asking us the distance traveled in this time interval, t plus 1 and this the next second after t plus 1. Okay. Now, okay, how to do? So constant acceleration, the acceleration is constant. So let us first look at this part of the journey. In this part of the journey, let us apply first equation of motion, v equals to u plus 80. How much is your speed over here? U plus 50. It increased by 50. So initial is u over here plus a into a. How much time interval passed? 1 second. So what do we get over here? A value comes out to be 50 meter per second square. Acceleration we got 50 meter per second square. Acceleration we got it. It becomes very easy to deal with your equation of motion. Next, let us apply second equation of motion, s equals to ut plus half at square. S, how much is the displacement over here? 125. This is equals to initial speed at this point. Initial speed at this point, u into time is 1 second, 1 by 2 into acceleration we calculated 50 into 1 square. So we get 25. Over here 125 minus 25 is u. Initial speed comes out to be 100 meter per second. It comes out to be 100 meter per second. Acceleration is this and initial speed is 100 meter. From this point, from tth second, if you consider, that means at the second second we have to find out the distance from this point, not from the starting. From the tth second we have to find out distance in the second. So we can use Sn is equals to u plus a by 2 2n minus 1 relation. I hope this point is okay. And now from this specific point, from tth second, the second, this is 1 second, this is the second. So Sn is equals to u, initial speed we calculated over here 100 plus 50 by 2, 2 into n value is 2 minus 1. I hope this point is okay. 25. So 100 plus 25, 4 minus 1, 3. 175 meter. Okay. So the answer in the t plus 2th second, it will be traveling a distance of 175 meter. Right. Let's move to the next question. Yeah. So the question that we have is, it says the relation between time and distance x is t equals to ax square plus bx. T equals to ax square plus bx. Fine. Where a and b are constant, the acceleration is. They are asking us acceleration. Now relation between x and t is given. We know acceleration. What is our acceleration? Acceleration is dv by dt. Let us see. Mathematical, it's pure. We'll have to differentiate it and take a look at it. If I differentiate this equation with respect to time, so what we'll get it? 1 is equals to 2ax dx by dt plus b into dx by dt. Dx by dt is differentiation of position, which is basically velocity. So 1 is equals to 2ax dx by dt I am writing as v plus b into v. Let's take v common. 2ax plus b into v, right? This is our useful equation. We have got velocity over here. Now let us differentiate it once again with respect to time. If we differentiate it over here, we can write down, this is x term, this is over here, we have this x and v, two variables are there, so we'll use product rule over here. So if we differentiate it with respect to time, 0 is equals to, first of all, differentiation of this 2a dx by dt plus b is constant 0 into v plus differentiation of v dv by dt. Now this we can keep it as constant 2ax plus b. I am using the product rule over here, right? So what can we write? 0 is equals to 2a dx by dt is v into v, which is your 2a v square, plus dv by dt is acceleration a, 2ax plus b. Now if you notice carefully this equation, 2ax plus b can be written as 1 by v. So 1 by v is basically 2ax plus b. From this we can write down, we can replace this 2x plus b as 1 by v. Fine, let's rearrange it. So what can we write? Minus 2a v square into v is equals to a. That implies acceleration comes out to be minus 2a v cube, right? Just we needed to differentiate the function carefully. So finally our answer comes out minus 2a v cube. What is our option? Check the option. Option number 1 is our correct answer. Let's move to the next question. Okay, so the next question says, a body starts falling freely from height h, hits an inclined plane in its path at height small h. As a result of this perfectly elastic impact, fine. First of all, let us draw the situation. A inclined plane is there. I'll draw it like this. Okay, a inclined plane is there. And a particle is falling from a height of h. It is falling from a height of h. After traveling a distance, that is, it hits an inclined plane in its path at height small h. That means this one. This one is your small h. Okay, over here perfectly elastic collision happens, no loss of energy. The direction of the velocity of the body becomes horizontal. So it moves like this. Okay, it becomes horizontal. The value of h by h, capital H by small h, for which the body will take the maximum time to reach the ground. Maximum time to reach the ground. How to deal with it? Now this journey we can break down into two paths. One is your motion under gravity, straight line motion, right? Basically particle is moving, motion under gravity, right? Straight line motion over here. Second is the particle, because it has gained horizontal velocity, it will perform your projectile motion. It will perform projectile motion like this. So two times, let's say this is the time taken to come down over here in straight path is your t1, time taken for this projectile path is your, in this projectile motion is t2. Let's see over here t1. If I have to write t1, t1 will be what? This part straight line for a particle which is falling freely. What is the time we can write it? Root over 2h by g, right? t2, t2 what can we write it? t2 is the time taken for this horizontal projectile. Again this is also given as what? Root over 2h by g. I hope I am using the relation over here formula. But this height, how much height, vertical displacement it is having? This total is capital H, this is small h, so this will be capital H minus small h, which, so t2 becomes 2 times h minus h by g. What is our total time coming? Total time comes t1 plus t2. So t is equals to root over 2h by g plus root over 2h minus h by g. This is our time. If we want maximum time, so what should we do? dt by dh. They are asking us relation between this with respect to small h, relation between small h and capital H, such that we get maximum time. For maximum time, we will differentiate this function and put it equals to 0, basically using maxima, right? So dt by dh should be equals to 0. Now, if we differentiate this dt by dh, what we will be getting over here? Root over 2 by g, because these are constant, and differentiation of root h will come out to be 1 by 2 root h. And differentiation of root h will be 1 by 2 root h plus again root over 2 by g can be taken out. This will be 1 by 2 times root over h minus h, and then differentiation of capital H minus small h. This will be your 0 minus 1. So this comes out to be minus 1 over here, right? We'll take root 2 by g common, 1 by 2 root h minus 1 by 2 times root over h minus small h. This is what we have got it. Let's put it equals to 0. If we put it equals to 0, root over 2 by g goes away. We are left with finally 1 by 2 root h is equals to 1 by 2 times root over h minus h. So, I am going in this reverse order. Please check it. So, h minus h is equals to root h. If we square it, h minus small h is equals to h. So, h capital H is equals to 2h. How much is, what is the relation coming? Ratio h by small h is 2. Capital H by small h value for maximum time is coming out to be 2, right? So let's move ahead. Let's look at the next question. Calculation, be careful with the calculation in this question. Remaining part is just writing down the time period for one is straight line motion, motion under gravity straight line, and another is projectile. Let's move ahead. Okay, so the question we have is, a particle moving in circle of radius r with uniform speed takes time t to complete one revolution. Fine. Circular motion, uniform circular motion, let's say that the speed is v, radius is r, and it takes a time of t. What can we write down time? T is equals to 2 pi r by v. From this, v can be written as 2 pi r by t. Well and good. Next it says, if this particle were projected with same speed at an angle theta to horizontal, the maximum height attained by it is 4r. Okay, in terms of r they have given the height. The angle of projection theta is then given by theta in terms of sine and cos they are asking. Fine. So, if this particle is thrown with the speed of v, this speed with which it is moving in circular path at an angle of theta, the maximum height is 4 times the radius. They are asking you angle theta. Let us see. What do we know in projectile? In projectile, maximum height h is given as u square sine square theta by 2g, right? Height, how much is our height? 4r. Let's substitute all the terms. 4r is equals to u square. U is our initial speed, which is taken as the speed with which the particle is doing circular motion. So v square we can put over here, this 4 pi square r square by t square into sine square theta by 2g. Let us rearrange this. Sine square theta is equals to 4r, which will be 8rg into t square by 4 pi square r square. Cancels out, 4 times 2 times. So, sine square theta is equals to 2gt square by pi square r, right? Sine theta. Sine theta is equals to 2gt square by pi square r. Theta value can be written as sine inverse of, basically root will come over here, one root will be there. So sine inverse of 2gt square by pi square r whole power 1 by 2. This is what the answer will be. Now you check it. Options. Sine inverse of option number 4. Option number 4 will be our correct answer, right? Let's move ahead. Yeah. So we have a particle is moving in one dimension under the action of variable force. Its initial position was 16 meter right of origin. Okay. So at t equals to 0, x is equals to 16. If we need it, we'll use this information. Let's see. The variation of its position with time is given as x is equals to minus 3t cube plus 18t square plus 16t. Okay. Where x is in meter and t is in second. The velocity of particle when its acceleration becomes 0 is dash meter per second. Now this question, identical question, means same type of question came in previous shift also. We have already done it, but let's solve it over here. Velocity will be what? Dx by dt. How much we'll get it? 9t square plus 36t plus 16. Acceleration is what? Dv by dt. How much we are getting? Minus 18t plus 36. So acceleration 0, that implies minus 18t equals to minus 36, which implies it is your 2 times. So at t equals to 2 second, your acceleration is becoming 0. Now we'll substitute in this. So v is equals to minus 9 into 4 plus 36 into 2 plus 36 into 2 plus 16. So this one will get as 36 plus 36 into 2 plus 16, which comes out to be 36 plus 16. How much it is, beta? 46 and 52. 52 meter per second. 52 meter per second is the velocity coming. है ना? Identical question, 2 times, means in 2 different shifts, same type of questions are asked. Let's move ahead. Yeah. So the question we have is, train A is moving along 2 parallel rail tracks towards north with speed 72 km per hour. Let's draw the situation. A train moving with 72 km per hour. That means, can I write it directly? It is 20 meter per second. 20 meter per 72 km per hour. And train B is moving towards south with speed 108. So parallel track B moving with 108, that is your 30 meter per second. We'll convert them because in answers they have asked in terms of meter per second. So we'll convert a kilometer per hour into meter per second. Fine. Velocity of train B with respect to train A. Velocity of train B with respect to train A, and velocity of and velocity of ground with respect to B. Velocity of ground with respect to B. Fine. One is going toward north, another is going towards south. North will be taken positive, south will be taken negative, obviously. Let's see. Velocity, relative motion, VBA. VBA. VB minus VA. VB, how much it is? Minus 30, and this one is A is 20. So how much we are getting? Minus 50 meter per second. Well and good. VGB, that is velocity of ground with respect to B. So VGB will be Vg minus Vb. Ground 0. This one will be your minus of minus 30, which gives us 30 meter per second. Right? Now check the option that are given to us. Minus 50 and 30 we are getting. That is your option number 3 will be correct answer. Right? Answers are there in front of you. Let's move to the next question. Okay, we have reached to our last question of this video. Let us see what it says. A particle starts from origin at t equals to 0. At t equals to 0, x is 0, y is 0. The position is at origin with a velocity of 5 I cap meter per second. So v value is basically 5 I cap. Okay, and moves in xy plane under action of force which produces a constant acceleration of 3 I cap plus 2 j cap meter per second square. Acceleration is constant, which is 3 I cap plus 2 j cap meter per second square. Okay, if the x coordinate of particle at that instant, at some instant, x coordinate is 84. Okay, then the speed of particle at this time is root alpha meter per second. So at this time, speed is basically your root alpha meter per second. You have to find out speed, that is alpha value, and we have to find out speed and then your alpha. This is motion in 2D. It's pure case of motion in 2D. We will deal with x direction separately, y direction separately, keeping time as common factor. Let us see. We know position 84 meter. At some position. Let's see what is the speed. So basically we'll have to use equation of motion in x and y separately. What can I use? Third equation of motion. Vx square is equals to ux square plus 2a into 2ax into displacement in x direction, which I am writing by x. Vx square is equals to ux square. Initially it was only x direction velocity, which was 5. So 5 square 25 plus 2 into acceleration in x direction, which is 3 into 84, right? So Vx, when you will solve this, Vx value will come out to be 23 meter per second. Okay, beta? Vx value will come out to be 23 meter per second. Now we have got 23 meter per second as our velocity. After how much time the velocity becomes 23 meter per second? Let us see first equation. Vx is equals to ux plus ax into t. 23 is equals to ux. Initially was 5 plus acceleration is 3 into t. So t value comes out over here 6 seconds. Right? 6 seconds. After 6 seconds, the velocity over here is becoming 23 meter per second in x direction and its position is 84. So after 6 seconds. Now let us calculate. We know the acceleration in y direction. Now let us calculate what is the velocity in your y direction. So what can we write? Vy is equals to uy plus ay into t. V equals to u plus at in y direction. Initially it was 0. Acceleration in y direction is 2 into time is 6. So Vy value comes out to be 12 meter per second. You have got Vy, you have got Vx at x equals to 84 after 6 seconds. So let us calculate V. It will be your root over Vx square plus Vy square, which comes out to be root over 23 square plus 12 square. When you will simplify this, your answer will come out to be root over 673. Okay, the velocity will come out to be root over 673. Therefore, what can we say? That basically alpha value will be 673. Answer. Okay, beta. So with this, we have completed our discussion of PYQ. Some 1 or 2 questions are there in which your basically your NTA also didn't give the options correct. I'll be putting the PYQ questions in that, you will find that part also. And remaining, I hope you found the video helpful. Do consider to press the like button and subscribe to our channel, and also check our revision series. You will find revision videos of motion in 1D and projectile motion and other chapters also, right? Thank you very much. Bye bye.